Welcome to Lab 2 instructions. You'll notice for Lab 2 that I actually assigned problems from two different labs, one on geologic time and one on your position on the Earth, which is latitude and longitude. And that wasn't to pile on the work this week. It was because I'm only giving you a few problems from each of those labs. And these are two topics that are pretty quick and going to be kind of fundamental for the rest of the semester. So this video is for the geologic time part, and the next video, part 2, will be for the position on Earth. So it starts out by talking about the concept of relative versus absolute age. So relative age is an order to events, but not with any numbers assigned. For example, I could tell you that I'm older than my brother, but younger than my sister. So you would know our relative ages, but you wouldn't know our exact ages. Now, numerical ages are just that. They are exact dates. So if I told you that I'm a year older than my brother and 3 years younger than my sister, and I'm 20 years old, which I'm not, then you would have an idea of how old everybody is exactly. So what's shown here is a similar kind of comparison. Here we have the relative ages of various wars, with the oldest war being on the bottom and the most recent on the top. And we don't know when they happened. We only know their relative order. On the right, however, these wars have been put on a timeline, so you can see exactly how much time was between them and when they each occurred. So the first thing you're going to do in this lab is on page 14, and it's activity 1. And please notice that I did not assign everything. I know I already said that, but you really don't want to do more than you need to on this lab. Okay, so activity 1 is just this page here, these two problems. And when you read it, you'll see pretty clearly that it's asking you to put a number of events in relative order and then assign them a numerical date. So that's pretty straightforward. The next 3 pages are activity 7, and those are a little more complicated. First of all, you want to read about activity 7 by reading the very top of page 21 and then page 22. And we're going to be looking at this geologic time scale with a bunch of fossils, because fossils can help us date rocks. If we know that a fossil was only around in the Cretaceous, then we find a rock with that fossil, we know we have Cretaceous rocks. So what you can see here is the Paleozoic, Mesozoic, Cenozoic, and then various organisms. And the brown arrows next to them shows the range of when this organism was alive. So for example, this little guy down here was only around in the Cambrian period. And then he went extinct, or it went extinct. Here's another organism over here that was around in the Devonian and Mississippian and then went extinct. Some organisms are around for a really long time, like the sharks. The sharks are first found in the fossil record in the Devonian period, and obviously we still have them today. They're an excellent predator, and they have not gone extinct. So a couple terms that you're going to be introduced to in this lab are index fossils and fossil assemblages. So index fossils are fossils that are widely spread geographically throughout the world, but only existed for a short period of time. So they're really unique in telling us what geologic time period the rocks are. Like my example with a fossil that was only around in the Cretaceous, you know that those rocks are Cretaceous. So this one down here that's only around in the Cambrian could be an index fossil. It tells us that this rock is Cambrian because this fossil wasn't around any other time. Sometimes we don't have index fossils, and we use a fossil assemblage to tell us the age of rock. For example, let's say we have a rock unit with these 3 fossils in it. We have a shark, so this rock unit could be anywhere from Devonian to Quaternary. We have this little spiral thing that's called Archimedes, and this was around in the Mississippian, Pennsylvanian, and Permian, and then it went extinct. And then we have this little guy over here, which was only around in the Permian. If you have rocks with all 3 of these fossils preserved within, the only age possible is Permian. It can't be older than Permian because this fossil didn't exist yet. And it can't be younger than Permian because 2 of the 3 of these went extinct at the end of the Permian. And so that's fossil assemblages. So what are you going to do? So you're going to answer these questions fossils as time indicators. And so this first question says, what is the geologic range of plants that belong to the group ginkgo? And so you're going to look on your timeline, and here's ginkgo. I've got it circled, and it came on the scene in the Permian, and it's still around today. So I'm going to blow up this page so you can see a little better. That's that same question number 1. So you're going to put on your page that it existed from the Permian period through the Quaternary period, etc. And you're going to go down this list of questions and do the same thing. Then when you get to the bottom, question 7 refers to a diagram on the next page. And it says, for A, determine the geologic range or age of each rock layer by its fossil content and write your answer on the figure. So here we're looking at assemblages. So here's that figure, and we've got 2 separated rock units. This one over here has a number of fossils in it, and every time you see a break, that means that it's a break in time between 2 different rock units. And then here's another rock unit at some distance. So let's start with the first one. We have these 3 fossils in this rock unit. The lepidodendron, I've highlighted here on our geologic time scale, was around from Mississippi into Permian. The dimetrodon was around here. And the ginkgo, we've already talked about, showed up in the Permian and is still around today. So what time period must this rock unit be? It has to be Permian, because that's the only time when all 3 of these organisms were alive. So that's what you're going to do for each of these different rock units. Now if I go back to page 7, that was A. Now B says, draw lines connecting the rock layers of the same age between these 2 outcrops. And so the outcrop is what we call these cropping out of rocks. And so what that means is, let's say that this period down here turned out to be Permian. Then you just draw a line connecting these 2 rock units because they're from the same time. So that's what that means. Here on the top of this page is part D, and it says, based on the age of the rock layers in outcrop 1, identify an unconformity. And it says, remember that an unconformity is a break in the rock record, and draw a wavy line where it is. So I'm going to just put a definition that's a little bit different, but an unconformity is missing geologic time from the fossil record. Sometimes there's no deposition of sediments, and that can be for millions and millions of years. And so the general term is unconformity. What they're asking you is to look at outcrop 1 once you've completed all the period names and see if there's a big jump. And I'm going to give you an example over here. So let's say that this rock unit here with the shark and that little ammonite looking thing, let's say this is Triassic in age. And then let's say this one down here is Cambrian, way down here. So we have a bunch of missing time. Now, these are not the right answers, but so you draw a wiggly line to show an unconformity. So that's what they're asking. Finally, activity 10. Now you're kind of lucky because we're not going to do the first part of this, which actually takes quite a while in class, where everybody gets into groups of 4 or 5 students, and you get adding machine tape like this, and you stretch out 5 meters of it with your meter stick, and then you draw all the organisms on the right hand side, this page 28, and you place them on the timeline with a mathematical relationship that 1 meter equals 1 billion years, or a millimeter equals 1 million years. And it's a bit challenging, but I don't really see a way that we can do it with you in your home. So we're going to skip that. But you are being expected to do questions 1, 2, 3 on this page. And I included the timeline just to kind of give you a different view of the timeline. Now this one is actually quite different because they have the beginning of Earth history here, 4,600 million years ago, 4.6 billion. The Precambrian is just this pink and peach area. So that's 4 billion years, but they've kind of squished it into the back of the figure. And then they've really blown up the Phanerozoic eon, the past 542 million years, to show the detail. That's what this is all about. Now, question 2 over here asks you to list the major animal groups in order of their appearance on Earth. And you obviously don't have a whole lot of lines to do that. So what I'd like you to do is just take a look at this diagram and look at the life things, and a lot of them are in red. The oldest known fossils, cyanobacteria or blue-green algae. Then there's the first multi-celled organisms, followed by invertebrates, fish, amphibians, etc. So just summarize the basic changes in organisms throughout geologic history, but really briefly, just because obviously there's not a lot of space. And that's it. That is all I've assigned to you for the Geologic Time Lab. So now you'll go to part 2, instructions for positions on Earth.